So I wanted to ask a pretty simple question. The future of the web, is there one? I think if you are paying attention to web application development, it might seem as though native apps have won and the web is kind of in remission. So I think it's a question worth exploring. But why am I qualified to tell you this? Well, I'm kind of not. I do a bunch of work in JavaScript. I'm on the language committee for JavaScript TC39. I'm on the W3C's technical architecture group, all of which is to say I'm kind of a bought-in insider in what just happened. I can tell you about the web as a platform, but I may not be able to tell you about the larger things that are happening around it. I may not be able to tell you anything about the environment in which we live, but hopefully you'll spend the next hour and we'll explore it together. So I don't have a crystal ball. If I did have one, it would be very, very, very hazy for all the reasons that I just mentioned. And all of that leads me to think that the way I should investigate the future is to think about related rates. It's to think about what has changed and the trend line that it's on. Obviously, every nonlinear eventually goes linear. Those sorts of truisms hold. We can't say that something's growing exponentially and it's always going to be that way, or that something is dead. It's always going to be that way either. But it's helpful to think about the trend lines as we kind of try to make sense of a bunch of conflicting data that I think our businesses and our projects are starting to encounter as we think about the platforms that we're building on. So what I can do is tell you, though, about the things that we just shipped. That's a thing that I am totally qualified to tell you about, because the teams that I've worked on, with, and in and around standards and inside the Chrome team are the teams that may have helped shape this stuff, but definitely we're on the hook for maintaining the code. So I can tell you about the stuff we just shipped. And it's actually a pretty great time to be a web developer. Someone was telling me the other day that how much they missed the good old days, and I was like, what do you mean, the good old days of web development? I was like, we have dev tools, you're insane. And so we totally won on the desktop, right? Ajax happened. Who uses a non-web-based email client on the desktop today? Okay, we've got 5 hands in a room of 6, I'm sorry. 6 hands in a room of something like 110, 150, something like that. Who uses a web-based email client? Okay, let's flip it around. On your phone, who uses a web-based email client? I've got 2 hands. Who uses a native email client on your phone? Okay, it's actually a straight reversal. So we won the desktop just in time for mobile to eat the entire world. That just happened. And it isn't necessarily the case that if I had asked the question, who's using web-based email client 10 years ago, you would have said, yes, you're using web-based email client on the desktop. That wasn't necessarily the case. There was a reversal. I used Outlook once upon a time. And not Outlook.com. I mean, the physical thing, you had to go out to the store and buy a CD and like, put in your drive and install with great anticipation. So it raises a bunch of questions. So where are we really? We've done really well. The web has done really well as a platform for delivering experiences on the desktop. We haven't, clearly, because you're reading your email, even if it's actually all being rendered in a web view, you're reading your email in a native app on a phone. We haven't really done well there. So where are we? How do we make sense of the kind of conflicting signals that we've got about the platforms that we're building for? If the web straddles all these platforms, what's its future? Does it have one? Where are we going? So your intuitions about your mobile experiences are not wrong. We see that something like 85% of the time, this is a 2014 statistic from Flurry, a company that does application metrics. They said that 86% of time is being spent inside of native apps and 14% of user time is being spent on the web. Now, there's a bunch of dark matter here. We don't really understand the extent to which the time being spent inside of native apps is being spent inside of web view wrappers around web applications. We don't really understand the difference between hybrid and native. These statistics don't tell us any of that, and in fact, that data is very difficult to get right now. But if you fast forward a year later to 2015, we're down a percentage, 87 to 13% from ComScore. So if we just fast forward another, 10 years, we're dead. All right. the web on mobile might as well simply be eclipsed. I don't think anyone would be paying attention below 10%, actually. I think that's probably where you just sort of stop bothering. And it could very well be the case that it is darkest before it goes pitch black. That is absolutely a possible outcome for our platform. Which brings me to Java on the desktop. So I still don't know about you, but between SWT and AWT and Swing, I sort of get kind of a nervous tick every time I see Java on the desktop. It has all the full fidelity with Java on the desktop that you could want, and not with anything else you'd want to use. And if you had told a Java desktop programmer in 2005 that the future of mobile development was going to be writing Java UIs, you would be excused for having been laughed at, I think. In the same sense, if you had told a desktop Objective-C programmer in 2005 that the future for them was going to be this explosion of the ability to write Objective-C in Cocoa and have it matter, I mean, you would have been met with a lot of optimism, I'm assuming, because I sort of went to those Macworld after parties with the band made up of old-time Apple programmers all pining for the near future in which everyone came to their senses and realized how much better the Mac actually was as an operating system, and they all went out and spent $2,000 at least on a Mac desktop. That was the future, right? That never happened, except when we went to mobile. So the fact that a platform seems totally dead or moribund doesn't necessarily mean that that's true. That may be a dominant narrative. And these reversals happen. These reversals happen frequently when we see changes in form factor, which doesn't really bode well for the web, actually, if you think hard about that. So is writing JavaScript and HTML a dead-end thing to do? Is the question that I think is relevant to this community and this group tonight. And I submit to you that the answer to that question has jack all to do with the technology involved. In the same way that the fact that Java is garbage collected and Objective-C isn't, or wasn't, or sort of wasn't and then was, and then... Anyway, you get the idea. Garbage collection doesn't make the difference between a successful platform and an unsuccessful platform, despite what you might have read. An interpreted language doesn't make the difference between a successful platform and an unsuccessful platform. Those things kind of matter at the limit, but you're almost never at the limit, turns out. Moore's Law has been working for us for 30 years. We've got a lot more headroom than I think we give ourselves time to think about it on a daily basis. It's not the tech. It's not the tech as we understand it today. It's not about the bits that we tend to fixate on when we're thinking about what makes the difference between a successful platform and a platform that isn't meeting our needs as users and developers. And so I want to ask the question, what is actually holding back the web on mobile? Now, I don't have a 100% answer. I've got a thesis, and hopefully you'll follow me through my thesis tonight, and if I'm full of it, I'd like to talk to you at the break and have it out, because I want to understand the world better, and I don't know what all the answers are, and so maybe you know more of them than I do. So let's keep talking about it. But I'll give you my thesis, and then maybe we can talk. And so my thesis is that partly what's holding the web back on mobile is this. This is a blog post from the W3C announcing a new mobile website validator. I don't know how you would read that on a mobile phone. You could maybe stretch it and zoom it and maybe pan back and forth while you're trying to do that to actually get from one end of the line of text to the other. That's a thing that could happen. You could do that, and then maybe you could read this blog post. At the same time, it's not necessarily mobile's fault in this case. This is what this web page looks like on a desktop, so, you know, responsive is as responsive does. So the mobile website validator blog post, at least it indicates a particular problem. And that problem is roughly that the web is the only platform that I know of that attempted to bring all of its desktop legacy with it to a constrained device environment. I remember hearing stories about how SVG plus J2ME was going to be the future of mobile development. Sun was really keen on this. They really wanted us to make SVG plus J2ME applications. But note, even Sun, in that moment of pure insanity, didn't suggest that you were going to bring AWT with you. That wasn't the dominant. You weren't going to bring Swing with you. That wasn't the paradigm that was going to come with you to that mobile environment. You were going to have a different set of tools. And so this is advice that last year, this is an image from the Google Webmaster blog, which gets tons of traffic. Everyone who makes websites and would like for them to show up well in Google's search rankings, which is most people who are trying to make money on the web, tend to pay some attention to what happens on this blog. There are a team of people who review each of the posts that go onto this blog and attempt to say something very clearly every time something is said. And they had to provide advice in the form of a graphic that says, don't do the thing on the left, do the thing on the right if you would like to make money. And had to do that in 2015. And it's 2016 now. And this is advice that we're actually having to give people, which is that if you would like to make money on a mobile device, you sort of should format your stuff for the context that people are in. So we have a cultural challenge between the way the web has assumed that it will be consumed and the way that we assume that we are going to make it, and for whom, and in which situations, and in which form factors. No other platform attempted to run all of its desktop legacy on a mobile device. You can't take a Win32 program and run it on a Windows phone. Not easily anyway, not without a lot of emulation that you bring yourself. You cannot take a desktop Mac application, a universal binary. Who remembers universal binaries, right? A bundle, a universal bundle. You cannot take a universal bundle and run it on an iPhone. Does not work. Will not compute. You cannot take a desktop Java Swing application and run it on an Android device. Doesn't work. Isn't supported. We made a switch to the form factors, and everybody else jettisoned their legacy baggage. They said, I'm sorry, we're just, that's crazy pants. You know, I've got this little, Cortex processor, and you're asking me to do what I did on an i7. No. And a mouse, and a screen this big. I got a screen this big. No, we're not doing that. But the web didn't. The web said, yes, we are the adaptive platform. We will take all of our legacy baggage with us, and we will run it. By that standard, I think we've done an admirable job. I don't think that you could say that browser vendors have been lazy at running all the world's web content on phones. We do. There aren't a lot of things we do that well, but this is a thing we do pretty well. Should we have done it well is maybe an open question. I don't know. Maybe it hasn't served you. Maybe it hasn't served us. It's unclear. But there's a bigger disconnect, which is that if you think about the way the web is constructed with the assumption that you have put yourself into the web mode, right? I don't know about you, but when I started using the web, you would do this thing where you would yell to everybody else in the house, parents, brothers, sisters, family, don't pick up the phone, I'm using the internet, and I need file 15 of this RAR set, otherwise I'm just not gonna, my day is gonna be ruined. But more importantly, you put yourself in that mode definitely when you sort of operated the computer, but you sort of sat down in a separate location, in a separate bit of the house, in front of the computer. You didn't take the computer with you, that wasn't a thing. Even if you had a luggable, that wasn't a thing you did. You went to the computer, and you put the computer and portions of the house in internet mode. And you were in internet mode, and so the assumption that everything on the web was just a link away, was just an HTTP request away, was a reasonable thing, because you were in internet mode, right? You assumed that the system was going to be set up to work roughly the same from moment to moment, because you had taken great care to ensure that that was true. That isn't the case on mobile. I've got a mobile phone, and that network can be in any random state, and frequently is. When I try to use it, it may be in a super low power state from the modem's perspective. It may have a low power mode, or I may be in 3G or 2G. To get out of the gates, to just have a conversation about a DNS request that I would like to make at some point in the future, I have to spin up a bunch of physical stuff, which I think most of us who are web developers never think about, which can be very slow on a network like a mobile phone network. And then I have to go spin up a TCP stack or figure out how I'm going to actually make that connection happen, and then I have to do all the dances that I was going to do, and hopefully that network is going to stay in the same state roughly the whole time. Meanwhile, I'm fighting buffer bloat, and I'm fighting a whole bunch of other stuff underneath me that I don't really understand. This is not the reliable network that we had come to assume, and which the entire web is premised on. We built a web that was premised on everything being one link away. Every hyperlink being the same latency, roughly, as the thing that I got to the first time. Mobile apps don't make that assumption. They haven't brought with them the assumption that everything in the experience is the same latency away. So they bundle it all up, they package it all up, they give it to you all at once. The entirety of the application experience is in that package that you download from the App Store. It's all right there. So we have this fighting us. We have the fact that we tell intermediaries and caches not to cache anything. Thanks, please give me this brand new content all over again. And we do the same thing on the response. We tell everyone from our servers, please don't cache this content. Because when someone comes back to me, I definitely want them to come back to me to get the fresh stuff. Because that's how you get fresh content, is you go back to the server and say, hey, what you got? Tell me what you got. For those of you who are Rick and Morty fans, show me what you got. And we do that every single time we want any new sort of content. All the time, every time, we make that treacherous traversal from our device through a series of networks which are totally unreliable, which we can't put into internet mode, because that's not how it works anymore. And we run that gamut every single time we want new content. This doesn't work as well as maybe some other models might. Which all leads up to the big problem, which is the web application model isn't really an application model. We start processing your content when you send it to us as if it's a brand new day. Every HTML document that we as a browser get, at the parser that Elliot maintains, gets, that parser takes a string of bytes and it reinflates it into a brand new world every single time you request a web page. That world is shiny, it is fresh, it has no relationship to the document that you loaded before it. There is nothing left over. We go to great pains to make sure that we've scrubbed the entire world away and that we start a brand new one. You've got a navigation bar at the top of your website. You've got a footer at the bottom. You've got left-hand nav, right-hand nav. That's common. We didn't know that. We don't have any concept of that as being related to the document that you were at before. That's a brand new bit of universe as far as we're concerned. The fact that visually I see it as being part of the same site, whatever. But we've got some things that persist a little bit longer. We've got some storage mechanisms that have this notion of an origin. We've got some stuff like that. But really, we're all sort of gluing it back up together, when in fact, the reality is that each single document is a brand new thing. And so the web has no application model built into it. An application would be a set of related experiences, all under a single umbrella, all under a single brand, that are tied together by a single entry point that you can get back to at any moment. We don't have that on the web. We've never built ourselves that advantage because we were able to get by without it. Now, that isn't to say people didn't notice. Who's used Adobe Air? Okay, 6 people. You should talk to your friends who use desktop email clients. I think it's a disjoint set. Maybe you've got some stuff in common. Adobe Air was an attempt to take web content and turn it into a packaged application thing that let you run both Flash and HTML together in a happy family, but it could be a standalone window. You could run it on mobile and desktop. It's pretty cool. WebOS tried to do exactly this. They said, great, the web doesn't have an application model. We will take web technology in the same way that Air did. We will package it up and we will give you the web application. We will give you a web application. It's not on the web, mind you. It's not launched at a URL in the same way that an Adobe Air application isn't launched at a URL. It's a separate package that you download and install separately. But remember, it's web technology. Cordova does this. Intel's Crosswalk project does this. It's a sort of a variant of Cordova with its own runtime built into it. Electron does this on the desktop. Electron takes Chromium. You may see browsers entirely based on Electron these days. It's pretty cool. WinJS and Universal Applications, Microsoft's attempt at this. They attempt to allow you to take your brand spanking bundle of content, download it, and run it locally, divorcing it entirely from the web. You're not on the web. You don't have a URL. You're no longer attached to that sort of universe of origins and URLs. Mozilla tried this. We tried this. It's a popular idea, right? It comes around a lot. People frequently say to themselves, the web has a bunch of problems. And those problems include the ability to get to content reliably, fast, all the time. We have an inability to access different bits of system UI. We can't be in the dock, we can't be in your alt-tab list, we can't be in your Finder, we can't be in your task switcher, we can't be your notification tray. The web doesn't have access to those things. And so those instincts give rise to an engineering solution, which is, well, the web's great, and people really want to write HTML, JavaScript, and CSS, and so what we should do is we should let them write HTML, JavaScript, and CSS, give it an XML or JSON or YAML, who knows, whatever. Some packaging format file, we'll run it through a tool, and we'll let them install these things from an application store, or maybe some other UI that we'll give them specifically inside of our browser. A very, very popular idea. But what they haven't realized is that the best part of nobody's day is HTML, JavaScript, and CSS. It's just not the case that what web developers want is HTML, JavaScript, and CSS. We like it, it's great, it has a bunch of advantages. It makes content searchable, linkable, indexable. It does great stuff for us. But that's not why we make websites. We make websites because of the distribution friction. And so, if we had an application model for the web, you could think of the bits that you would bookmark as being independent items at your site, right? Example.com/parts/item or some set of inventory or some sort of catalog. You have individual items in that, and those are things you bookmark. Those are individual items of content, which are inside of a shell, inside of a larger whole, but they're individual things that are being loaded into that shell. But what we don't have is a way of thinking about example.com as being an entry point to the experience. Because again, the browser has taken that example.com/parts/item and it's reinflated a brand new world. It doesn't have any notion that example.com is an application in this way that you would when you tap from something in your launcher or on your home screen or in your applications list. We don't have that concept in the web. Then there's offline. We made this very cute dinosaur game. Who's played the dinosaur game? Okay, so that's obviously a subset of Chrome users, but the dinosaur game we had to make very cute because you see this a lot, which is terrible. I don't do very well at this. I wish I had a higher score. But despite all of these problems, the fact that the web frequently gets you into this terrible mode of not being able to solve your own problem or get to the content that you know is right there, or you had it in the cache, why aren't you just giving me the freaking page? Despite the fact that the web has all of these problems, why is it that we're doing so well in e-commerce? Because we're doing really well in e-commerce. My colleague Alex Komrowski spent a bunch of time digging into data over the past year to try to understand, in that 14%, 13% of time that people are spending on the web on their phones, what are they doing? And the answer is they're buying stuff. And buying stuff, there's a ton of steps. You have to type in on the worst input device you can imagine for typing in specific dates and locations, your address, a shipping address, a credit card number, which you can't get wrong, an expiration date for a credit card number in a format which is different on every freaking website. And yet, we are buying things on phones, and we are buying more things on phones, both absolutely and relatively, every year than we did last year. We are spending a ton of time and money on the web buying stuff in an environment that's clearly not suited to it. So what? Why? Wouldn't it be better to just have an application in which you could buy things? Is a question that I think would be natural to ask. Because we spend a ton of time and money on websites buying things. It's interesting. It's really interesting. There's a lot we can do to reduce the friction. The Chrome team and other teams have been trying to do that, but we are doing, by and large, very, very, very well selling things. It's also the case that 80% of the time that people are spending on phones, on mobile devices, is being spent in a very small number of applications. So about that 86%. What is 86%? Well, if 80% of that, 86%, is being spent in the top 3 applications, that's an interesting dynamic. It means that there aren't that many things that you do on a phone, or you do them inside of a very few number of unique entry points, which plays out in the marketplace pretty directly. So this is a stat from a company called Fixu, who does marketing for applications and application installations, and this is the dollar price for a user who installs a native application if you are going to use ads to sell those installs. This was a growing market. That number was $1 at the end of September in 2014. A year later, it was $1.50. It's going up for both iOS and Android. And in many cases, for many sorts of verticals, getting a user into an application costs as much money as you can expect to make. Building a native application and then getting it in front of a user costs so much that it is frequently a poor choice. Then there's the question of zombies. A lot of the applications that are listed inside of app stores never see updates. They're not findable, you can't get to them. They don't show up in searches, and they're definitely not on those recommended lists, which means that they have very few installs. The incentive to build these things is obviously clear. If you win the distribution lottery, then you can do quite well, potentially. But if you don't, you may be the unwitting victim of a long life. So it is the case, then, that building a native application is very much like buying a lottery ticket. I don't know about you, but I don't have that much math background. But I certainly am not about to go start trying to put food on the table every week by buying lottery tickets. It doesn't seem like a reasonable thing to do. Maybe you could win big. And lotteries have the reputation they do because people do win, right? In the same way that people are one of those top 3 applications. There are those top 3 applications do exist, and you and I probably spend a lot of time in them. At the same time, most of the applications that you and I build probably aren't those top 3 applications. It's not the case that every application is going to be a top 3 application by definition. So there's a real pinch, there's a real winnowing of the opportunities that are available if you're going to try to have to get through that very expensive funnel to get your application in front of users in the native application environment. So here's more advice we actually had to give to developers in 2015. We actually had to tell people, please, 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 don't keep people from using your website. Please don't smack them in the face with a big banner that says, please install our application. And the reason that you might build a website that does this super nasty, terrible, unfriendly, inaccessible thing to an end user is because you think that there's so much value in having them inside of your application versus having them in their website. So it's worth thinking about what is that value. So we know that people use about 27 different applications on their mobile phones every month. Nielsen did this report last June. This is corroborated by a couple of other sources. It's in this ballpark. But we see that they're also using 100 or more sites, individual URLs at top-level navigations. These are not iframes. Places that you would go on a given month. And I think this has a lot to do with that e-commerce success we were talking about. It's not worth it as a user to go to an app store, sit there through that process. Holy cow. Every single time you want to get back to something. It's easier in some cases to go type something into a search box and say, hey, give me back that thing that I had, as opposed to going to try and carve off some valuable screen real estate on your home screen to get back to it later. So I submit that distribution is the single hardest problem in all of software. I will be told I'm a fool by my colleagues. I'm eagerly waiting with an open inbox. But I believe that distribution is the single hardest problem in software. I saw this firsthand when the Chrome team was very young. I joined the Chrome team when we had less than 1% of the world's users using Chrome every day. And the rise from 1% to a lot more than that took a very long time, and it was very hard, and it required a huge uphill battle to go convince each and every individual user that this experience was going to be better for you, to find a way to help convince them. And it took, what, half a dozen years to get to a place where Chrome is a thing that people know of as a brand. The same thing was true for Firefox and IE back in the day, and Netscape back in the day before that. Like, these are not slow shifts. They don't happen quickly. And distribution is really hard. And the web changed distribution fundamentally. The web meant that you didn't have to go convince someone to go to the store and buy your shrink-wrapped piece of software. That you didn't have to go convince them to download a sketchy installer off of downloads.com. That was no longer part of your daily experience. You could type in a URL, get to the service that you wanted, and just be using it. There wasn't an installation process. This hasn't escaped notice. The web fundamentally changed the way we think about distributing software in a way that no one else has really come back at. There sort of isn't a response to the web yet. All the native application stores that we use on our mobile devices today feel to me very much like the digital equivalent of driving to Best Buy and picking up a shrink-wrapped copy of the latest game. They are an excursion. They are definitely high friction. And it is the friction that matters. So let's say that I convinced, let's say there was 1,000 people here, and I convinced you to go try out my new air horn application, which is located inside of a native application store. What people who are pretty experienced in the native application space have said is that you lose about 20% of your potential funnel every time you have another action. Okay, so let's say there's 1,000 of you who are into it. 800 of you might go to the store, and then find it in the store, and then click install, and then accept permissions, and then download will wait, and then click to use it. We're down to 262. If 25% as a success rate is winning, well, it sort of tells you why maybe people don't install that many applications. It's expensive, especially if data is expensive. Okay, what if I could get you directly into the install flow? Okay, you click the install button, you have to accept some permissions, you download, you wait, and then you find it, and then you use it again. We're still less than 50%. Whereas if you had clicked on a link, you were already there. And this hasn't escaped notice. Big publishers, people whose job it is to get their content in front of you, who have a direct line relationship between wanting you to read their stuff and getting you that experience, are saying, sorry, we're doing the web because it's lower friction. It is friction. Friction is the thing. This is the atavist. The previous one was The Verge, which is a property that I think belongs to Vox. And so what we see today is that the mobile web that we are experiencing has enormous reach, but it doesn't really keep users engaged, right? At 86 to 14% number again. That time spent isn't being spent on the web, even though people go to more websites every month. It's really fascinating. The amount of time being spent really does skew towards native applications. Why is that? So I submit, and this is again part of the thesis aspect of this evening, that a lot of it is home screen access. Your thing isn't something that I can call back into easily. If you build a website, it's hidden behind a search box and a bookmark UI instead of a browser, and the browser icon, potentially. I have to go back into the browser and then go find your thing again. I can't be notified. It's not sitting in my notification tray, and it certainly doesn't work offline, so I don't really trust it. It's not very trustworthy. It's not an experience that I know is going to work for me. So home screen access. You can today click on Chrome, go to an air horn application, click on this button, go to Add to Home Screen, okay, and then you can click Add. This is really frustrating. It takes a long time, and that's terrible. Because on the one hand, you have no idea whether or not this thing is going to work well offline if I do choose to save it to my home screen. There's no indicator for me as a user that this is going to be an app-like experience, that it's going to meet those contracts that applications meet on a regular basis. If I tap on it, is it going to give me an offline dinosaur when I'm not connected? Or is it going to tell me something that it knew? Is it going to give me the experience? Is it going to do all the things that I want an application to do? Is it going to sync some data? Is it going to always be there? We can do better, and I think one way to do better is something that Francis Berryman and I, Francis is the back, termed progressive web apps, which is the idea that you would start with something that is a website that progressively becomes more like an application. And we need some technology to get there, but we don't need very much, which is interesting. So let's talk about it. So this is the air horn application I was just showing you, but in Chrome today and in Opera soon, you can go through this flow, where if you go to it twice within a particular period of time, in this case, 5 minutes, have to separate the navigations, you'll get that prompt at the bottom. That is browser-provided UI that we show you that says, hey, we think this thing is going to act like an application if you choose to save it to your home screen. Do you want to keep it? You know, this isn't your first landing, or it's not just here to spam you. You've been to it before. We think this is probably an experience that you're going to like, and we know that it meets all of the needs that you might have in terms of like being a real application. This is a thing that you can do today, and you can try this out in Chrome for Android. Again, soon for Opera. And the way we do this is, you may have seen this diarrhea at the top of web pages that you work on or have view sourced on. This is pretty bad. There's all this stuff. It's all repeated. It tells you about the icons, the colors, but you have to put this into every single page you go to tell it that this thing is an application. Obviously, these are very scarce and precious bytes. This is not a great place to be doing this. It would be better instead if we could just link from a single file at the top of this document to a metadata file over on the side, which we could share across multiple documents perhaps, which would give us the notion that all these documents were part of the same application. And so that's what the Web App Manifest is. And the Web App Manifest is the spec that we developed in collaboration with Mozilla and other folks in the community to basically allow you as a developer to say, hey, this thing is an application. And to do it, you have to provide, to get that UI at the bottom, you have to provide a short name, a start URL, which is to say if I tap on the icon, where am I going to go? You have to have an icon that's at least 192 by 192 PNG in Chrome. Other browsers will have other requirements for that. You don't have to have an orientation or a GCM sender ID. So the ones at the top are what you really need, but you also have to have a service worker, which I'll tell you about in a little bit, so that we know that your thing is going to work well offline. And that's it. That's the whole shebang. That's how you get to this experience. But it takes a lot more work than that to actually make your thing work well offline. So I want to show you one of these experiences that our friends at a company called Flipkart, which is one of the largest e-commerce retailers in India, have built in the last year. They launched this just before Diwali in India last fall, and the experience is incredible. This is it being demoed in Chrome, but what you'll see here is that their UI is really fluid. It's very fast. It is 60 frames a second for almost all of its animations. They've done a really great job in terms of optimizing it, so it feels like a native application. But if I keep going to this application over time, there's a little button at the top that they've implemented where they decide to control when that little browser-provided UI shows up at the bottom. It only sort of jiggles at the top like that once they've got a signal from us that we would like to install them. But what you just saw there is that, again, it launches full screen when launched from that shortcut. And that full screen application shows up as its own item in the task switcher across all versions of Android. It has that splash screen that you just saw. That splash screen is partially generated by us and partially by them. We use the icon and the color that they specified inside their manifest to generate the background and to use the icon that they put in their manifest as the thing we put in the middle and that short name at the bottom. So the experience is very app-like. There's no flash of white. You're not ever going to get an offline dinosaur because this thing will always do something, even when you're offline. This is a sort of a brand new kind of experience for the web. And splash screens are pretty critical to this. The metadata that I just showed you inside that web app manifest is all you need to get the splash screen. You can provide a background color for this. The Flipkart folks have done a good job here. And we're going to continue to expand the capabilities of the splash screen API. I know other browsers have other plans for it. But again, this is an open spec and an open standard that we're continuing to evolve. So how does it work is an important question. They launched this last fall. Does it work? The answer, I think, is yes. It's important to understand that Flipkart is an interesting test also, not just because they launched a website that's this good, but because last summer they had also turned off their mobile website. It was the case that they had made a judgment call that said, well, you know, native apps, they perform really well. They have all these advantages. They're reliable. Users who are even in very flaky network conditions, which they frequently are in India, can use this application. They had said that maintaining a mobile website across a ton of different browsers was just too much work. It was just not working for them. So they shut it off. And they came back to the web when it could do this, when the web could actually deliver on the experience that they wanted to deliver to their users. They came back. And so the question is, if you build an experience this good, does it matter? And the answer is yes. People are spending 3 times as much time inside a Flipkart Lite as they did inside the old site. That's pretty good. And they're also seeing 40% return visits week on week. I don't know about your e-commerce or retail site, but most people would kill for this. And perhaps most important number is conversions. They're seeing a 63% increase in conversions for users that come back to the Flipkart Lite experience from that home screen icon. For exactly the same reasons that applications work. Being able to be persistent, being able to be right there in front of you, being able to be re-engageable. Flipkart Lite has managed to create many of those advantages for their web experience without having to build a native application to get it. The other aspect is push notifications. You're going to hear a lot more about that later tonight. Owen and Nate, Owen from the Chrome team and Nate Schloss from Facebook are going to be telling you all about how they have managed to make that experience work well. And Martin, who's helped work on the push protocol, will be telling you more about the backhaul, or certainly the security aspects. But push notifications are kind of the new frontier in making UI for the mobile experience. And traditionally, web applications have been shut out of push. Not anymore. Firefox for Android and desktop, and Chrome for Android and desktop now support a compatible web push notification system. And this push notification system allows you on a site like Product Hunt, again with a prompt at the bottom, to opt into this. And these notifications appear in your system notification tray, wherever that might be, on desktop and on mobile. And these notifications work even if the browser is closed. The browser doesn't have to be running. The tab doesn't have to be visible, doesn't have to be anywhere in your tab stack. This stuff works exactly the same way native applications do. It requires a service worker, which I'll tell you a little bit about in a second, as does the add to home screen prompt. And it needs a permission. The user has to accept that permission, like I just showed you, but it doesn't require an installation phase. You don't have to go to a store. There's no heavyweight upfront thing. You go to the site, and you can a la carte choose to opt into notifications on a site. It isn't a binary, I chose to install this application, therefore I get notifications sort of question. Which means that we can start to re-engage people from lightweight experiences that they just happen to fall into. But if you want to keep some piece of that experience going, you can ask them, hopefully respectfully, to get re-engaged through push notifications. Owen will tell you more about this, but Beyond the Rack is an early case study that we've been able to work with them to implement, but also to help understand how it's going. And they're seeing huge repeat traffic as a result of push notifications, increase in time spent for users who come back to their site via push notifications, and again, an increase in conversions based on the ability to be re-engaged through a new bit of UI surface area. So the last piece is offline that works. It isn't okay to be on the home screen and not meet the basic contract of, I will do something when tapped on. It isn't an app if it doesn't work when you tap. And that means that we need to do something better than Google Gears. Dion's here. He's actually going to kill me, I think, later, because I think he doesn't know that I was going to use this slide. The Chrome team, before it was the Chrome team, built a system called Google Gears. And Google Gears tried to bring offline to the web. And so it did it with a system that said, hey, give us a list of your files, and we'll give them back to you when you ask for them later, basically. We'll take a manifest, and we'll give you the contents of those files that you listed in the manifest at some point later when you ask for them. It was reported by the early Gears team members, there was a choice that they had. They said, well, we could build a programmable network proxy, which sounds like a lot of work, or we could build this thing where you give us a declarative format full of files, and we'll just go slurp them all down and give them back to you when you ask for them later. And Gears also provided the first version of SQL storage. It provided the first version of web workers. So it had a bunch of the pieces. You could have combined workers with this stuff, but they sort of just took one road, and there was a road not traveled. And a couple of years later, we rebuilt that exact system inside of HTML5, and we called it application cache, the HTML5 application cache, which took a slightly different colored list of files and would give them back to you later, including the file that you were looking at that referenced the list. And it turned out that this worked just as well as it did for Gears, which is to say, not at all. It was completely undebuggable. And in fact, the Google team that went and built application cache could and should have known that this wasn't going to work, because there was an entire team of people who had tried to build Gmail for offline and Google Docs for offline, and that didn't work. Well, it sort of worked, but it required a lot of heroics and effort. In exactly the same way that this article was written by Jake Archibald, who helped design the service worker spec, after he had successfully launched a site that worked with application cache, right? This is not a victory lap. This is not a, hey, we did it. This is a, you got to be kidding me. So again, same system style, same basic architecture, didn't work. And unfortunately, it didn't work everywhere, which is to say we implemented this very, very broadly. You can use application cache on pretty much any browser today. You'll hate your life, but you'll hate your life portably. So we started the Gears project in 2006 to solve offline for the web, and we failed roughly for 10 years. So we failed because we tried to take a high-level thing and come up with the one way to do it that we knew was going to work for you. And in fact, it didn't work at all because we didn't know what you needed. So we're going to try something totally different now. It's called Service Worker. And the way Service Worker works is that you get to write some code, and you get to decide what to do at the moment where a network request is made, or when somebody needs a bit of sub-resource, or an extra bit of data, or something when you may or not be offline. So we make this up to you. We give you a programmable cache, and we cache a script that you give us, and we say, we're not going to cache other resources. You get to do that. We're not going to go cache your files. That's your thing. We're not going to tell you when you're offline. I mean, you can detect when you're offline. That's on you. You get to decide what to do at every single moment. It's a programmable network proxy. And so the way it works is that you get to add an event handler for the fetch event every time that you want to handle something. You can have more than one of them to compose things together. And because it uses promises, you can do things like work with a cache API that's asynchronous, or work with IndexedDB in an asynchronous way to make sure that you're not blocking this network thread, in much the way that Node.js programming is totally asynchronous, cooperatively multitasked. So think of it this way. Traditionally, you go to example.com, and you get a response back. And if the network doesn't work, you don't get a response back, and you get an offline dinosaur, or you're staring at a white page for a long time. That sucks. Instead, now, you can try to go to example.com, and if example.com had previously installed a service worker in the background, now you can choose what to do. You can say, I'll tell you what I got right now. I'll give you the resource I had in the cache, and if I get a request for some JSON stuff, I'll give you what I've got again, but maybe I'll go to the network for some updated stuff, and if I get that, I'll post message it back to you, so now you can update the UI with the new stuff. All of this is up to you. There's not a pre-programmed strategy. That strategy is definitely something that you have the ability, on the one hand, to implement, and on the other hand, to break. So good luck. The way this works is that it's entirely event-driven. It's best effort. It executes when it's there, and it doesn't when it's not. That is to say, the first time you land on a web page, there isn't a service worker. We're not going to wait and hold up the whole world for loading that web page the first time just because there isn't a service worker, which is good because, you know, there are some browsers that don't support service workers. So it's good if your application works even when they're not there. These things can be shut down between events. They're not unceremoniously killed, but we don't let them run forever. They're very event-driven. We wake them up when we need them, and we turn them off when we don't. That means that you can't sit there in the background hogging tons of memory, which is a lesson we learned the hard way with the Chrome extension system. And there's only one active system service worker at a time for a particular scope. That is to say, if you've got multiple tabs that are all looking at example.com or some subdocument of example.com, and you've got a service worker registered for the /path at example.com, they'll all be talking to the exact same service worker. There won't be more than one of them, not one per tab. It's just one-to-many relationship between the service worker and the controlled documents. So, all right. The best way to think about service workers is that they are a programmable network proxy, but they are also progressive enhancement for the network, because you start life in your application without one. You always have to. The way this works is you go to the Airhorner application, and it works the first time because it just serves you the content from the server. And in the background, it actually goes and installs the service worker using code like this, where it says navigator inside the document, navigator.serviceworker.register. You pass it the location of the script, and at some point later, it downloads it and then runs the install phase in the background. So it works like this. You start without a service worker, you install it. There's an activate event, which lets you do a bunch of stuff. Between the install and the activate event, you have a lot of time. Nothing is being asked of you yet. You're not being asked to handle resources. Nothing is on you. You've got to be able to go download and cache a bunch of stuff in the interim between when your application is first experienced and when you think you're actually competent to handle things offline. And then maybe you'll get put to sleep. Maybe you won't be used. Someone comes back to your application. Some point later, maybe you'll get used, but you'll get stopped probably. But if you get fetched again, you'll be restarted, and then you'll have to handle some stuff. And then you'll maybe go idle, and then you'll maybe get stopped. This is the lifetime of a service worker. It's not particularly complicated, and the upgrades work exactly the same way. When we detect a byte-for-byte difference in the service worker, we install the new one in the background. We go back to the installation phase. While the old one's still running and handling tabs, we go download and install the new one in the background, and then when it's ready, we send it the fetch events instead. All of this gives rise to something that we're calling the application shell architecture. The app shell architecture lets you take your application and do that thing that we were talking about before, where there's a bunch of stuff around the outside, a header, a footer, left nav, right nav, bottom stuff, all that stuff that's common to your application, you can cache that and install it inside the service worker cache, and you can always serve it to the user, no matter what content you may or may not have inside the application itself. Once the service worker is installed, you can make sure that that application shell is reliably available all the time. And then you can load content. You can host content inside the shell, but the shell can be durable. It can be something that the user can always get to. Because it can be the top-level HTTP response, you can get pixels on screen without ever going to the network, which is a huge win. You never have to sit there and wait on DNS, socket connections, HTTP, and TLS setup. You never have to do the thing where the radio comes out of a low power state. And if you're on a 3G connection with a relatively good RTT, Ilya Grigoruk put this slide together for Velocity a couple of years ago, and it's correct. You can't get to less than 1 second for pixels on glass if you're in a 3G connection in a low power state. It's just not possible. But when you have a service worker, you always can. You can always put pixels on glass in less than a second. This is the difference between an application platform that has a reliable experience, a reliable delivery of your application versus one that's not trustworthy. Service workers give your application the chance to finally deliver a trustworthy user experience. You can put something on screen, even if it's your own offline dinosaur, to say, hey, I don't have it. At least it's your fault. The application platform didn't let you down. This matters. The impact of speed on bounce rates for applications that are dealing with money is tremendous. This has been documented over and over and over and over again. If you go to any of the videos of the past Velocity conferences, you'll be beat over the head, roughly, with all the data that suggests that making your thing faster makes you more money. It's true, and yet our things are slow. Part of that's a platform problem, and you have a chance now to use the platform to help you fix it. So one of the important things that you can do here is to make sure that you use what we call the cache-first architecture. Flipkart does this today. If you haven't used Flipkart on your Android phone, I suggest you try it out. You go to flipkart.com, then you go into offline mode. They gray out the entire UI to show you that you're in offline mode, and they'll let you go look at the things that you had previously searched for and the things that you'd previously looked at, the items that you looked at. But you obviously can't take transactions because you have to be online for that. But you can do most of the things that the application would let you do. But this is how we get rid of the offline dinosaur. We build this cache-first architecture that always pulls stuff out of the cache when users ask for a top-level resource. And then we let the application tell the user, hey, here's the current state. Here's what I can do for you. So service workers are becoming more and more reliably supported by the day. They are the fundamental thing that you need to implement in order to get that add to home screen behavior and to take advantage of the push notification features that you'll be hearing about later tonight. They're in Firefox today, which is great. They're in Chrome, they're on Opera, and they are coming soon to other browsers. They've been in Chrome for about a year. Opera has had them for a while. Firefox just launched them. I could not be happier and prouder to have our friends from Firefox in the audience tonight, because they just launched this, and this is a big deal, because they launched this and they launched push notifications for Firefox at exactly the same time, which is a heck of an accomplishment. It took us an extra 6 months to get push done. And Microsoft has signaled some intent. I can't say more than intent, but it's positive intent, and we are extraordinarily excited to have had them at the latest face-to-face meeting as well. So this is stuff that finally will hopefully make it possible for us to build true cross-device, cross-platform applications at a lower price than building it once for iOS and once for Android and once for the desktop web and once maybe for the mobile web if you have any design and development resources left. This is a way for us to finally get back to the place where we can deliver experiences and get reliability and re-engagement without spending 3, 4, 5 times the burden, or splitting our development teams into 3 or 4 separate channels, or slowing them all down to deliver it 3 or 4 different times, or give each platform a substandard experience. This is finally the ability for us to do better than that. And so with your help, I would like to create the extinction event for the offline dinosaur. And with that, thank you very much. We'll have questions later.